Hello and welcome to this lecture. My name is Sumit Kumar Chobe. I am assistant professor here in Department of Electronics and Telecommunication Engineering at Pune Institute of Computer Technology. Today I am going to discuss some of the most important questions that are being asked again and again in University of Pune examination for the subject signal and system. So let's start this session. So the first very important question that is asked again and again in this examination is initial and final value theorem for Laplace transform. Now this question has been asked repeatedly in every examination in last 3 years, especially for course 2015. Let's see what kind of question we are getting here in this Laplace transform. So this is one of the questions that has been asked in University of Pune exam 2016. As you can see here, you have been given access and you have been asked to find out the value of small x of 0 and small x of infinity. This is what is called initial and final value. This is another exam which has been asked in 2017. You can see again you have given a access capital X of s and you are asked to find out what will be the value of x of 0 and x of infinity. So this is a very simple question and it can be solved in 6 lines, but from in my experience I have seen that about 90% of the students that appear for the University of Pune examination are not able to attempt this question. So for that reason I am making this lecture. So let's see what we mean by initial and final value. So the statement of initial and final value theorem is very simple. It says that given that Laplace transform of a signal x of t is capital X of s, then x of 0 plus will be equal to limit s tends to infinity s capital X of s, and x of infinity will be equal to limit s tends to 0 s capital X of s, provided here there is a condition, provided no poles in right half plane. But in other words, what it means that x of infinity will be equal to this limit only if all the poles are in left half plane or there is a simple pole on s is equal to 0. So let's say a very basic example and then we will move forward to the University of Pune examination paper. Okay, so I'm going to select a very simple question. It is 1 upon s plus 1, given that x of s 1 upon s plus 1. So what will be the value of x of 0? So the value of x of 0 plus will be, according to our initial value theorem, is that s tends to infinity s capital X of s, and if you apply this formula here in this problem, you will get limit s tends to infinity s divided by s plus 1, and this is basically infinity by infinity form. So what we generally do here is that we divide it by s. So this will be limit s tends to infinity 1 divided by 1 plus 1 by s, and if I put the value of this limit, it will be here I will get 1 upon 1 plus 0, which is equal to 1. So this is a very simple question. You can see that I got the value of x of 0 plus in just 3 steps. Now we are going to find out the value of x of infinity. So x of infinity is the limit s tends to 0 s multiplied by x of s. Here it will be limit s tends to 0 s divided by s plus 1, and if you put the limit directly, you will get this is 0 divided by 0 plus 1, so you will get 0 answer here. So in just 4 lines you are able to solve this problem and you will get 6 marks here. It's free of cost marks. One important point here to make is that you get actually 1 marks for writing the formula. So for example, you will get 1 marks for writing this formula right here, and another 1 marks for writing one formula right here. So you can see this is a very simple problem. You will get just 2 marks for writing this formula, and 2 additional marks for finding out this correct value and finding out this correct value. So this is a very simple problem. So let's move on to the University of Pune problems. So this was one of the problem that was asked in University of Pune examination in 2016, and as you can see here that x of s is given, and we are again set to find out the value of x of 0 and x of infinity. So what will be the value of x of 0? Limit s tends to infinity, s capital X of s is given here, so it will be limit s tends to infinity s times 5 s plus 50 divided by s into s plus 5. Now here you can see that it is again a infinity by infinity problem. So what we are going to do is that we are going to divide here by the maximum power of numerator and denominator, and here in this case you can see that maximum power of numerator and denominator is s square. So this will be limit s tends to infinity, and actually we can cancel out this s of s. So we can divide it by s, then it will you will be getting 5 plus 50 by s divided by 1 plus 5 divided by s. So it will be again 5 plus 0 divided by 1 plus 0 equal to 5. So you got your answer of x of 0 plus, which is equal to 5 here. Now x of infinity will be equal to, we don't have any right half pole here in this problem, so it will be directly equal to limit s tends to 0 s into 5s plus 50 divided by s into s plus 5. So we can cancel out this s and this s, and when you put the value of 0 you will get 50 divided by 5, which is equal to 10. Okay, so again here in this question you will get 1 marks for writing this formula, another 1 marks for writing this formula. I haven't written this formula. This is one of the mistakes that students usually make. You should always write the formula first and then try to solve this problem. Okay, I simply wanted to save some space and want to explain this problem in this page only, and that's why I haven't written the formula. But you should always write the formula. Never make this mistake. Okay. So next to the next problem that has been asked here in University of Pune examination. Here we have given again a x of s, and we have to find out the value of x of 0 and x of infinity. So value of x of 0 plus here will be limit s tends to infinity s capital X of s, which is equal to limit s tends to infinity s multiplied with s plus 10 divided by s square plus 2s plus 2. Okay, so again you can see that it is infinity by infinity form, and what we do when we get infinity by infinity form, either we should use L'Hospital rule, which is very simple, or we can simply divide it numerator and denominator by the maximum power of s. So the maximum power of s here you can see is that it is s square. Here again it is going to be s square plus 10s, so it will again s square. So if you divide it by s square you will get limit s tends to infinity and 1 plus 10 by s divided by 1 plus 2 by s plus 2 by s square. So you will get 1 plus 0 divided by 1 plus 0 equal to 1, and the final value theorem will be x of infinity equal to limit s tends to infinity s capital X of I have made a mistake, sorry, this is not s tends to infinity, rather than it is s tends to 0 s capital X of s. So you will get again limit s tends to 0 s multiplied with s plus 10 divided by s square plus 2s plus 2. And if you this is 0 by 2 form, it is not, you are not going to get indeterminate form here. So this is 0 divided by 2, which is equal to 0. So it's as simple problem as that. Some of other problem that has been asked in Laplace transform are inverse transform, finding out inverse transform of Laplace transform, which is again a very simple problem. You should not face any problem while solving this problem. Okay. Another question that has been asked is to find out the Laplace transform and draw the ROC and inverse Laplace transform again and state and prove the convolution property of the Laplace transform. Another problem that has been asked from this unit is you can see the finding out of the Laplace transform, and the differential equation has been given, and you have to find out the value of output for this particular input. So this is again a very simple problem. Okay, if you work for 2 or 3 days on Laplace transform, you are definitely going to get 13 marks out of 13 marks. One question is always going to be initial and final value theorem. It's definitely going to be initial and final value theorem. So best of luck for the examination. Thank you, and do watch my next lecture which is coming on, and in this lecture I am going to discuss some of the common problem that you can get from the last unit, that is 6th unit. So do watch that. Thank you.